Hi guys, how are you? For today, I'm going to be discussing another basic structure of discrete mathematics, and this is all about matrices. So, what are matrices? I'm going to be starting off with the definition. A matrix is a rectangular array of numbers, and to visually see an example of a matrix, I would want to point you to example number one. This is a matrix, okay? And the size of this matrix is 3 by 2. So how did I find the size of the matrix? It's important for us to know the size of the matrix because we will be using them later as we solve problems. So guys, listen to this. So how did this come to be known as a 3 by 2 matrix? So in counting the size or naming the size of the matrix, all you need to do is to determine the number of rows and columns it uses. So, like for instance, this one, okay, we have here the rows 1, 1, 0, 2, and 1, 3. And that is actually three of them. So, that denotes the 3 over here. And we have two columns, which are 1, 0, 1, and 1, 2, 3. So, there you go. That is how you find the size of the matrix. So, remember, in figuring out the size of the matrix, we are just concerned with row times columns. Okay, so I hope you got that. Let me move forward a little bit. Next topic is all about matrix arithmetic. So matrices, we could actually do some mathematical manipulation, and we do have two of them presented today. This is the first one is actually the sum of the matrix, and then later on, as an exercise, you'll be able to determine the product of a matrix. So how do we get the sum of the matrix? By the way, the sum of the matrix is denoted by this one, A plus B. Okay? So be careful, guys. Okay? Sometimes it's not possible for us to do the sum of the matrix. There are some restrictions. Okay? Let me proceed to example number 2 here. As you can see, we have here two given matrices. Okay? And let us first determine the size. Okay? This is actually a 3 by 3 matrix, also a 3 by 3 matrix. So a matrix with those equal rows and columns, we oftentimes call them square matrices. So this is the rule for doing addition. Okay, both matrices should have the same size. Okay, you cannot actually add a 3 by 3 matrix with that of a 4 by 2 matrix. So that's impossible. So again, for you to proceed, you must have two matrices of equal sizes. So let's try looking into the solution now. As you can see, we will just be adding them as is. Okay, so 1 plus 3, you get there 4. 0 plus 4 is 4. Negative 1 plus negative 1 is negative 2. So it's quite basic. It's an easy way to solve the problem. Okay, so I hope we're done with that of matrix addition. So another operator, as what I've mentioned, is the matrix multiplication or the product of a matrix. The product of the matrix is merely represented as this one. So this indicates what? A times B, denoting the product. Okay? Now, just like addition, there are rules to follow for you to figure out if a matrix, by the way, a matrix is solvable, okay, if they are defined. So when we say defined, they abide by the rules. So if I'm going to be asking you if matrices are defined, you just have to answer yes if they abide by the rules. If they do not, they are what we call undefined. But look at the example given here. This is example number 3. How do we know that the matrix is defined or we could actually solve? Okay, so let's look at the size of the matrix. This is actually again, we are going to count the rows first. This is a 4 by 3 matrix, and this one is a 3 by 2 matrix. So how do you know if it's defined? So I'll cite an example here. Again, we're dealing with the 4 by 3 matrix and a 3 by 2 matrix. For you to figure out if they're defined, all you need to do is to compare. Okay, you see this part here? Okay, they have to be equal. Okay, the last number of the size and the first number of the second matrix size should be equivalent. Okay, so what will be the size of the resulting matrix? That's a good question. Now, the size of the resulting matrix will now be coming from both ends. Okay, so you'll have you will arrive at a 4 by 2 matrix. So that's how you determine the size of the matrix. Okay, then there will be an exercise later. You are the ones to discuss this one, the extra example. We're going to be solving for the matrix given above. Okay, you will have to demonstrate to me how we come up with this particular solution.